All right, folks, welcome back. This is day 10. This is day 10, Friday, right? So this will after today's session, we'll close week 2 of our three-week course. All right. So today we'll be starting module 7, and in this module we look at a bunch of services. One being Route 53, which is a DNS service. We've seen this before, right? We'll talk more about this, and we'll look at a bunch of management tools. For example, CloudWatch is a monitoring tool. CloudFormation is a provisioning and deployment tool, right? So we'll look at those kinds of tools as well. And remember, we're talking now more about production and live environments, right? So in the initial part of this course, we looked at the basic building blocks of a stack, right? And now we're looking more at live environments, production environments, and we're also trying to look at more services because as a solutions architect, especially, you need to have you need to know, well, if not all, most of the services, right? Because you have to sort of design an architect, and you have to be able to pick the right service for the right problem, right? So that's why in this module, and also in the next module, we'll take a look at a bigger set of services, just to give you some more width in your knowledge about AWS. All right, so this is where we are, right? So we've done the basic services, and we've started looking at production environments, and especially in the previous module yesterday, we looked at how to do highly available, scalable, fault-tolerant sites using the load balancer and auto scaling. Right now, going forward, what we'll do is especially in modules 7 and 8, right? Today. And then we'll start module 8 on Monday. We are looking at 10 services. Okay, so that's a big number. 5 services in this module, 5 services in the next module as well. And there's no theme. There's no theme to each module, right? So it's an eclectic mix of services in these 2 modules, right? And the idea being to expose you to a wider set of services, because that's important for a solutions architect. All right, so 5 services today, and then 5 services in the next module as well. All right, now also, now that we're entering the last week, right? Next week is the last week of this course. Let's talk a bit about modules 9 and 10 as well, which will be on Wednesday, Thursday, and Friday, right? So in module 9, we'll be looking at a very important service. This is identity and access management, IAM, right? And then a couple of other services like OpsWorks, which is more of a deployment and automation tool. But the main service there will be identity and access management. This is the service which is used to sort of control access to the AWS account, right? It's different from other kinds of controls like firewalls, right? So it's a account privileges control, right? So the authentication side as well as the authorization side of who can do what with your AWS account, right? So that's a very important service. Again, very important for live and production environments, right? Any company which has a team of people using AWS will need to use IAM. So that's coming up in module 9. Actually, it's a bit late. I would prefer, I would prefer that we should have done this module a little bit earlier. But the course has been designed in such a way that it's in module 9. Okay, so it's very important. That's coming up in module 9, and then in module 10, module 10 is essentially an open session. We'll just have a Q&A. We can talk about some services we've not discussed. We can do a relook at some of the services we've already covered. Some of you, I think, based on the feedback, it looks like some of you are still facing problems with connecting a client to the server. So those kinds of issues we can cover in module 10. But before that, what we'll do is we'll do a mock test. Okay, so this is, we'll do a test using official AWS questions. This is just a very short test, 7 to 8 questions. That's it, right? But these are official questions, which is very important, I think, because it gives you some sense of what you can expect in the exam. Right? This is for those who are interested in the AWS Solutions Architect certification exam, the associate level exam. Right? So we'll do that mock test, and then we'll discuss each question, and I will also, give you some additional information about the exam. Some tips, some strategies, right? So that kind of thing we'll do in the first hour, of this module, right? And the remaining time we'll use for general Q&A. And I'm going to create a new sheet in our shared document where you can enter your agenda in advance, right? So you should enter your agenda for module 10 in advance, because I may need some time to prepare. Right, so that's what is coming up next week, modules 9 and 10, right? And of course, now today and then on Monday and also on Tuesday, we'll do module 7 and 8, where we're looking at an eclectic mix of services. These are in categories such as compute, management tools, messaging services, right? So that's what is coming up. Okay, so today, we'll do Route 53 and some management tools, right? So we need more time. So we'll need the first hour of Monday as well to finish this module. So we'll look at some management tools today, and of course we'll start with Route 53, which is a DNS service. Okay. Let's also do a review of module 6. It's a very important module. Even though we've spent less time on this, it's a very important module, because one of the main functions of a solutions architect is to ensure high availability, fault tolerance, and scalability, right? So the way we do it, is basically using the load balancer and auto scaling groups, right? Now things are changing, by the way. At this point I should also tell you that now we have this container technology, right? Docker, and also there are ways of sort of managing the containers. So there's a service called Elastic Container Service in AWS, right? And there are open source projects like Kubernetes, right, which help you manage your containers. So those are emerging as improved ways of doing all this, right? Getting highly available, fault tolerant, scalable sites. Okay, so that's something that you should watch. It's still early days, but you should watch that trend. And what we're doing here, what we saw in the module yesterday is virtual machines, right? So a bunch of virtual machines in an auto scaled group behind a load balancer, right? And the auto scaling group can change based on the load or the demand, right? So if there's more usage, more users are sort of using your site at any given time, the number of servers can automatically increase, right? And also the number of servers can decrease automatically based on if the load goes away, right? So you can manage your resources better. You can scale your resources easily. You can also save cost, because the auto scaling group can scale in as well, right? Not just scale out. Okay, so this is what we've seen, but I think all this will change. All this is changing. We'll soon have things like Docker taking center stage, right? So that's happening. You should watch that. But in this module, what we've seen is auto scaling groups consisting of EC2 instances, which are virtual machines, right? And Docker containers are actually a different kind of virtualization, which is happening within virtual machines. All right. Okay. So what we saw with the load balancer, especially, is it's basically the function of a load balancer is to distribute, right? So your users will sort of hit the load balancer, because your DNS name points to the load balancer, right? So all requests come to the load balancer. It's a central place where you receive all the user requests, and then the load balancer will forward the request to servers running behind it. You can have as many servers as you want, right? Large companies will have hundreds and thousands of servers, right? But a small company should have at least 2. Okay, at the minimum you should have 2 servers, because that gives you fault tolerance, right? One server goes bad, at least the other one is there. All right, and also those 2 servers should be in 2 availability zones, right? So once you have the setup, the load balancer will basically distribute the traffic using round robin, right? Round robin, the first request goes to the first server, second request goes to the second server, third request goes to the first server, and so on, right? So that's the main algorithm, but it also has some other capabilities. For example, it can find out which server is overloaded, and not send more requests there, right? So it has some sophistication, but at the heart of it is a simple round robin type of load balancing. Okay, so that's the load balancer, and then we also saw the auto scaling group, which is essentially instead of using standalone EC2 instances, we discussed that we should use an auto scaling group, right? Even if it is a fixed group, auto scaling groups are better because they are self-healing, right? So they can fix themselves. If one server goes bad, that is replaced intelligently, remember, right? So so if a server goes bad in zone A, the replacement also comes up in zone A, right? So in that sense, an auto scaling group is better always, almost always it is better than using standalone instances. All right, and also remember we saw the scaling side of things, right? So we have three types of scaling. Manual, you can do it manually, simply change the desired capacity. You can do a scheduled pair of policies, right? So you can say, in the morning, set the desired capacity to say 4. In the evening, set the desired capacity to 2, right? So this way you can save a lot of money because you only increase the capacity when you need to, right? And then finally, you also have a fully automated or a dynamic scaling policy where, based on the load, based on CPU, for example, you can increase the number of servers or decrease the number of servers. Okay, so and then this combined load balancer and auto scaling groups combined with RDS's multi-AZ deployment option gives you a very simple way of setting up your stacks, right? So this was module 6. Okay, let's talk about module 7 now. So here in these two modules, 7 and 8, we are looking at at a total of 10 services, right? So 5 today, okay, or 5 in this module, and we'll start with route 53. This is a DNS service. We have seen this before. We've used it a lot, actually, right? And we've seen some simple routing where we have pointed our domain names to say the EC2 instance, right? The elastic IP address, for example, or we have pointed the domain name to an S3 bucket where we are running maybe a website, a static website. We've also seen how to point a domain name to the load balancer, right? So that's simple routing, and but Route 53 can do much more. It has some advanced routing as well. So we'll talk about that, and also we'll take a look at a bunch of management tools, and management tools. These are sort of maybe not as important as core services like EC2 or S3 or VPC, right? But without management tools, you won't be able to make use of AWS, right? So without management tools, your effectiveness would not be as good, right? So in that sense, management tools are very important. For example, CloudWatch helps you monitor your infrastructure, right? So you know whether a server is up or down, right? You know what is the CPU utilization of your servers, right? So information like this, and without this information, you don't know what's happening, right? Therefore, you can't really make effective use of AWS, right? So that's what management tools are, and of course they make more sense in when it comes to live and production live environments. And when you're seriously using AWS, right? So we look at four management tools in this module. We won't be able to finish all of these today, right? But we'll probably do 3 of these. Okay, we'll do 3 of these today, and the tools are basically CloudWatch, which is monitoring, CloudFormation, which is infrastructure provisioning, infrastructure as code, basically. So you can automate the creation of your infrastructure. That's what CloudFormation is. Very powerful tool, right? And CloudTrail is like an audit trail, and Trusted Advisor is like a advisor. It tells you when you're not following best practices. Okay, so this is the agenda, 5 services, right? Route 53 and 4 management tools. Now, in terms of time, what we will do is we'll spend maybe an hour on Route 53, right? An hour on Route 53, and the remaining 2 hours on the management tools. And the second hour today, we'll look at 3 tools: CloudTrail, CloudWatch, and and Trusted Advisor. Right? For CloudFormation, we need more time, so we'll do that on Monday. Okay, and we'll also use a new sheet, right? For every module, we're using a new sheet. So we have this one here, Mod 7 other services. Okay, so this is the sheet. If you don't have a link to this document, please let me know. All right. I also had, asked you folks to, supply some feedback. I think very few people have done so. So if you can complete the feedback as soon as possible, maybe even now, right, while we are starting this module, even now you can do it, or maybe just after today's session. Right, so if you can do that feedback, that'll be great. Now, I think I've looked at the feedback. Some of you have filled up this form, and it looks like those of you who have done that are mainly concerned with the support, right? So I think one of you is not able to sort of connect or do hands-on activities. I think one of you has mentioned the use of Windows, right? So seems like some of you prefer the Windows, are using Windows, right? Maybe most of you are using Windows on the client side, right? I'm not sure about the server side, right? Server side, I don't know. I mean, my recommendation, right? If you're starting out, my recommendation on the server side would be to look at Linux, right? Because I think Linux is used. It depends on the industry, I guess, right? I think maybe in larger enterprises, maybe Windows is still around, right? Still there, but definitely in the startup world, in also product companies like say Google, Facebook, I think it would be more Linux on the server side, right? So if you're starting out, maybe my recommendation would be to start with Linux on the server side, right? On the client side, doesn't matter, right? Doesn't matter what you use. Most people use Windows. Some people use Mac, right? These are the two major platforms on the client side, right? And of course, you also have people are using phones more and more, and other types of devices where Windows is not there, right? So yeah. So and as far as the use of a Mac for the demonstration is concerned, it's not I think it's not a big issue, right? Look, doing an SSH connection is a very small part of this course, right? And it's just an SSH connection. It's the same protocol. You just have to use a different SSH client, right? Once you do an SSH, once you open a SSH session, it's the same. Steps, right? So I don't think a Windows, whether it's a Mac, the demonstration is done on a Mac or on a Windows, is important, right? And it's a small barrier. I do know that a lot of people get stuck at that, but if you should be able to troubleshoot through it. Okay, but what we'll do then is, I think some of you have asked for more time after the class, so we'll spend some more time today. All right, so we'll spend some more time today. We'll look at some connectivity issues that you may be having, especially from a Windows client. Okay, so we'll do that, and then also on Monday we'll do a weekly a weekly review, right? So last week as well on Monday we spent some time, right? So over the weekend maybe you'll practice some of these labs and some demonstrations, right? So we'll review that on Monday. We'll spend some more time after the class, after this regular session on discussing any problems that you're facing. Okay, yeah. So if you can, fill this survey, that'll be very good. Okay, because it might, we may be able to incorporate some of your suggestions in the remaining time in this course, right? Or of course, it helps us in general for future batches as well. All right. Okay, folks. So now let's begin module number 7. Okay. So the first topic is Route 53. This is a DNS service. Okay, so this is it's called Route 53. 53 is you might know 53 is the default DNS port, Okay, that's why the name Route 53. It's a good name, right? It's a clever name, and it's basically, a DNS. It's a DNS service, right? So, what is a DNS service? One of the major functions of this service is that it maintains the records, right? It maintains the records of the resolution. So if you have a domain, where should this domain be pointed to, right? Which IP address, right? So that's the record sets that have to be maintained in a DNS service, right? And that's what Route 53 does. It's also called an authoritative DNS service, right? So it's the authority, it's the final authority. It knows the absolute correct information, right? And why it is called the authority server is because when the DNS name has to be resolved to an IP address, the question doesn't always come to the authoritative server, right? So you may have local DNS servers, you may have cache, you may have results cached locally or at an ISP level, right? So you may have information at various levels in the network, right? And you don't always go back to the authority server, right? But the absolute correct information is always with the authority server, because that's where your domain and your record sets are maintained. Okay, so in the picture here, you can see, when you type a domain example.com in your browser, it has to be resolved to an IP address, right? And the way it is resolved is the browser has to go to a DNS server or a resolver and get a response back from that, right? And if the resolver has cached the record, then it can serve the user straight away, right? Or if the cache has expired, or if it is not yet cached, then the DNS resolver will have to go to the authoritative server, right? And that's what Route 53 is. All right. Okay. Now, a service like Route 53, right? It's a DNS service, and a few things about this. It seems very simple, right? We have seen this before. Simply, point a domain to an IP address. It seems very simple, but behind the scenes, it has to be, a very high quality service, because remember, a DNS service has to be highly available, right? It should always be up, because you may have your stack set up with the load balancers, auto scaling groups, and all that, right? You may have hundreds of servers, but none of that will work if your DNS server is not working, right? If your domain name cannot be resolved, none of that matters, right? So because a DNS is such an important part of the internet infrastructure, right? And the DNS services like Route 53 have to be highly available, right? Much more so than any normal application, right? They're very important to the functioning of the internet, right? So they are highly available. They have to be up all the time, right? That's one. Two, they have to be scalable as well, because no matter what, how many times, how many people visit a certain website, say Facebook or Gmail or any other website, right? They may use these services all the time throughout the day, right? So a lot of DNS requests may be going out. So and also the usage may be very spiky, right? So during certain time zones, the number of requests may be very high. During certain events, right? Let's say there's some major news event, right? At that time, a news media site may be very popular. So it has to be highly scalable as well, right? The DNS service has to be highly scalable. And thirdly, although it's not mentioned here, it has to be very fast as well, right? Because users expect fast performance, right? So when you go to a site, you want the site to be fast, and a part of the performance is the DNS resolution, right? So if your DNS service is slow, then the whole site becomes slow, right? And you'll be blamed, right? You're blamed, but actually it's your DNS provider who's slow, right? So that's the thing about services like Route 53, right? Behind the scenes, they have to work very hard to have a service which is highly available, highly scalable, and very fast. Okay, so that's what Route 53 is. All right. Now the other stuff that's on the slide here is that we have seen simple routing, right? Before, in the previous modules, we've seen simple routing where you can point a domain to an IP address or to an alias, right? So that's a simple routing. But Route 53 also gives you some advanced routing. So for example, there's something called weighted round robin. There's also something called latency-based routing, right? And there's actually two more. There's geolocation and DNS failover as well. Okay, so there are four advanced routing policies that you can create. So weighted round robin is basically where you're at a DNS level. You can send requests in a round robin fashion, right? For example, you may have two stacks, right? Two stacks, one with, say if you're doing A/B testing, right? If you're doing A/B testing, product A/B testing, one stack has version A of your application, another stack has version B of your application, and you can do weighted round robin where some requests are sent to one stack, some other requests are sent to the other stack, right? So at a DNS layer, you can do some round robin type of routing. Okay, latency-based routing is where the user is sent to the stack which has the best latency, right, for that user. So you can have stacks in different regions, right? Using latency-based routing, you can set up multi-region stacks. So active-active disaster recovery type of solutions where you have stacks running in multiple regions, right? And the user is sent to the region which is best for that user, right? So that's the kind of thing that you can do with latency-based routing. Okay, and then there are others as well. So you have geolocation routing and DNS failover as well. All right, so this is Route 53. It's basically a DNS service. Okay. But it also has certain other functions, as you can see here. The first one, the one in the middle, is what we have spoken about, right? So you can basically point your domain to destinations, and you have these simple and advanced routing. All right, but you can also Route 53 also has health checks, right? The one on the right is a health check feature where you can this Route 53 can basically ping your stacks, and if your stack is not responding, it knows that your site is down, right? And if it is down, then it can take some action. For example, it can fail over, right? So it can fail over to maybe another standby site, right? So health check is another feature of Route 53. Also, if you look at the left side, the box on the left, this is domain registration, right? So you can register your domain, right? So it's not just a DNS service; it's also a domain registrar, which means you can buy a domain, right? So any domain you want, you can pay the appropriate amount, right? Usually it's like $10, $12 a year, something like that, unless the domain is very popular, right? So you can basically register a domain, pay the $10, $12 a year, and you can sort of buy the domain, and you become the owner of the domain, right? And then you can create your record sets using Route 53. Okay, so it's a registrar as well. But one thing that you have to note here is that you don't have to register the domain through Route 53 only. Okay, so you may have an existing domain. Maybe you bought that on GoDaddy.com or some service like that, right? So that's fine as well. You don't have to register the domain here, right? The domain can be registered. You've registered the domain elsewhere, or you've registered the domain many years back, right? So those things are fine. You can still use Route 53. Okay, so I'm going to explain all that, but that's a very important point to note, that you don't have to buy it from here alone, right? It's an option here. Okay, and the setup becomes simpler. All right, so if you register the domain here, then the whole setup becomes simpler, but it's not necessary. All right. Okay. Some information about the pricing. So you have basically when you create a domain on Route 53, it's called a hosted zone, right? And for each zone, you have to pay $50 per month. All right. So that's it's not covered under the free tier. And then the queries. So whenever someone goes to your domain name, right, and Route 53 resolves that domain to an IP address, right, that's a query, right? So each query, each request becomes one query. right? So the cost of that is half a dollar per million queries, right? Which I think is pretty low cost. Okay, now if you have advanced routing like latency-based routing, the cost there is slightly higher for the requests. Okay, all right. So this is the pricing. Now let's do some demonstration here. Okay, so what I'm going to do is there's actually four advanced routing uh, policies, right? So let me just show that to you, and then I'm going to show you one of these. Okay, I'm going to show you one of these, and because once you know one, you can implement the others as well. Okay, it's the same process. So we'll understand how to set up the domain, right? A little bit about how do you buy it. If you bought it elsewhere, how do you set it up? So we'll talk about that a bit, and then we'll look at one of this an implementation of one of these advanced routing. So maybe DNS failover. Okay, first of all, let's understand how all this works, right? So a DNS failover is a routing policy, right? So there are four advanced routing mechanisms that are available. The first one here is DNS failover, right? So what happens here is you have two sites, right? So let's say you have a primary and a secondary, right? And the primary, in this case, in this picture, the primary is the EC2 instance, right? And the secondary is a S3 bucket. So you have a static website in your S3 bucket. Okay. So and by the way, you can have anything, right? Need not be EC2, need not be S3. You can have both static websites. You can have both EC2 instances. You can have load balanced stacks, right? That doesn't matter. Okay, your stack and how you set it up doesn't matter. It can be anything. All right. But what DNS failover does is you have a primary site and a secondary site, right? And if the primary site is not functioning, right, if it is down, then Route 53 will fail over to the secondary site automatically. Okay, so this you can use, you can use. In fact, all your stacks should have something like this, ideally, right? Where if your site is down for some reason, right? Maybe there's a problem with the whole region, right? That your stack is running in, and so what you want is some kind of DNS failover, maybe to a static site where you display a message saying, yes, we are down. We're sorry about that. We'll be working on it, right? So that kind of simple DNS failover you can have, or you can also failover to a secondary site, which is like a DR, right? It's like a real secondary site, and you can failover to it so that you have higher uptime. Right, so what you do with the primary and the secondary side is up to you, right? But in this demonstration, what we're looking at is how DNS failover works. Okay, so I'm going to demonstrate this to you, but before that, let's also understand the other routing mechanisms, right? So the other one that's available with Route 53 is geolocation based routing, right? So what happens here is depending on the location of the user, right? And the location of the user can be determined at a country level or at a continent level. Okay, so for example, you can create rules where you say, look, if the user is from India, right, then send this request to a certain stack, right? And there you may have a version of your application which maybe runs in a certain language, right? Has different pricing, different legal terms, and so on. Okay, and then you can have a default rule where all other users are sent to another stack where you have a different kind of content, right? So you can create many rules also, by the way, right? So you can have one rule for, say, India, one rule for China, let's say, right? One rule for Philippines, and so on. So you can have many rules where, depending on the location of the user, the request is forwarded to a certain stack, right? And then you have a default rule where all other users, right? All other users are set. Okay, so this kind of thing you can set up as well. All right, then you have weighted round robin, right? So here it's a round robin, but with some weight. So you can say, the first stack has a weight of 75%, second stack is a weight of 25%. So 3 or 4 requests will be sent to stack 1, stack A, right? And 1 of 4 requests will be sent to stack B. Okay, so this kind of thing you can do. A use case here is product A/B testing, right? A/B testing. So all product companies do A/B testing, where they try to find out, they may have different flavors of a feature or of an application, right? So maybe, you have a certain page. They may show some people the page in a certain color, say blue color, right? Certain other people are shown the same page with a different color, just to see what works better, right? So they do all these kinds of things all the time. This is called A/B testing, right? And that's what you can do here using weighted round robin, where let's say most of your users are sent to the normal feature, normal implementation of that feature, right? And then a smaller subset of the users is sent to to a new flavor of that application, just to see what happens, right? So this is another routing mechanism available. All right, the last one is called latency-based routing, right? So here what happens is you have stacks in two different regions. Okay, they have to be in two different regions. In the previous slides, right? The stacks don't have to be in two different regions, right? But here they have to be in two different regions. Let's say you have a stack in the US region, and then the second stack is somewhere in Asia, let's say in Singapore, right? And what happens is, let's say a user is in the US, right, and goes to your domain name. So that user will be sent to the US region, because that user will see the lowest latency from this region, from the US region, right? Whereas a user in some Asian country will probably be sent to the Asia region, because for that user, the latency will be lowest in the Asia region, right? So this is a latency-based routing. The use case here is active DR, right? So you have a disaster recovery type of setup where your application will be up even if one whole region is down, right? A region being down is a very, very rare occurrence, right? But if a region is down, your site will still be up, because all the users, right, will be sent to the other region. Okay, because latency-based routing, Route 53 will determine that one of the regions is not, the latency is too high, right? So it knows the latency, and it knows that one region has very high latency, or it is not functioning at all. So it will start sending all the users, no matter where they are from, right, to the secondary region. Okay, so this is a DR site, an active DR site that you can set up using latency-based routing. Okay, so basically Route 53 is a very powerful service. It has many use cases, right? So for a solutions architect, I think it's very important to learn about Route 53, because you can use it, right? It's a very good sort of item in your toolbox. You can think of many use cases around this service. Okay, all right. So this is Route 53. Now let me show you one of these, right? So let's do this one, DNS failover. Okay. So what we're going to do is I'm going to create a primary site. Maybe this will be an EC2 instance, and a secondary site. This can be a S3 bucket, right? So I'll have a static page, something like, sorry, we're down, right? And the primary site will obviously have some kind of application, right? And then we will implement DNS failover at the Route 53 in the Route 53 service, right? And we will test this by stopping this EC2 instance, right? Just to simulate, just to see what happens when the primary site is down, right? So we'll stop this instance, and then we'll try and see that we'll see how Route 53 will sort of fail over to the secondary site. Okay, so this is the demonstration. Let's implement this. Okay, so first I'm going to create a primary site, right? Let's create a primary site. This is going to be an EC2 instance. We'll do the usual stuff, right? So just a simple HTML page on the EC2 instance, right? So let me go ahead quickly and do that. All right, so all this is something we've seen before. All right, so this is going to be our primary server, right? This is an EC2 instance. Let's just wait for it to be launched, And in the meantime, let me create our secondary site as well, right? So this is going to be in S3. It's going to be a static website, right? It doesn't have to be this way. You can have a EC2 instance as your secondary site as well, right? So all right, okay. So now we're going to create a secondary site on S3, right? And let me create a bucket here, and I'm going to, let's say our domain is DNS failover dot com. Right? So it's just a dummy domain, and let's say this is our website for which we're creating this failover scenario, right? This is our bucket here. All right, so this is our bucket, right? And in this bucket, we need to set up our secondary site. Right? So this is going to be, this will have, let's say, a simple HTML page. In fact, I have this page already. So let's say this one, right? DNS failover.html. And here we simply say something like failover, we hope to be back soon, right? Something like that. So this is going to be our secondary site. Let me upload this HTML page here. All right. So this is our home page that we are uploading at this moment. Right? Now, while this is happening, we also need to take care of making this this S3 bucket into a static website, right? So we need to sort of set up the static website hosting section here, right? So we'll make this bucket. We'll say that this is going to be a website host, right? And we also have to supply the index document, which is a home page, right? This we have done before. So this becomes a static website host. All right. Okay. And now we also need permissions, right? This is also something we've done before, where we created a bucket policy to make this website a public website, right? So same thing. We're doing the same thing here, and I'm going to use the policy generator tool. It's a free tool, right? And I'm going to say this is an S3 bucket policy where we want to allow everybody, right? Get object access to this bucket, right? And the bucket has to be specified using the ARN notation, right? So this is the bucket. All right. So this is how you create a bucket policy. You can then copy this. Copy this. This we have done before as well, right? So I'm doing it a little bit fast. So this you can copy here and you can paste into the policy editor button. All right. So this becomes our bucket policy. So now we have the permissions as well, right? So now this bucket is ready. It's a secondary site, right? So this is our secondary site. We can test it as well, right? We can test it. Let me click on the link here, and you can see this is our message. This is the page from the secondary site. All right. Okay. I think one of you has some audio problems, right? So Satyam, I hope others are okay, right? I hope others are okay. If not, please let me know. But Satyam, looks like problem on your side. All right. Okay. So let me just send a message to him. Yeah. Okay. All right. So let's see. Okay. So this is our secondary site, right? We've set up a secondary site, and basically what we're doing is this, right? We are basically trying to set this up. So we have our secondary site ready, right? Now let's go to the primary site. This is going to be an EC2 instance. Once again, the same stuff, right? We've done all this before. So let me SSH into this server here. All right, let me SSH into this, and this is our Ubuntu server, right? It's a server, Ubuntu server, and we'll do apt-get update, right? Because we want to install Apache web server. So let's do that, and now let's install Apache, right? So this, so that we can set up a simple HTML application, which will become our primary site. All right. So once again, what I'm going to do is I'll remove the default Apache web page, right? And in its place, I will create my own web page. All right, and here let's just say something like, this is let's say DNS failover demo, right? And also let's say that this is the EC2. This is EC2, right? The primary site. So that we can, we can make out the difference. When the failover happens, we need to know that it has actually failed over. That's why we need to have different pages on the primary site and the secondary site, right? So this is our primary site, right? Let's test it. So let me copy the public IP address, and I'm going to test this. Okay, so this is our primary site, right? So we have both sites ready, and now we need to see what we're going to do on the DNS layer, right? So Route 53. Okay, so let me open up another tab here, and now. All right, so now let's go to Route 53. Right? This is a service under networking, and here. First of all, let's talk about Route 53 a bit, right? So we've seen this before, but not we've not talked about it much, except setting up record sets. So first of all, you can see that you have domain registration here, right? So you can actually type a domain here, see if it is available, right? Getting a good domain is very hard nowadays, okay? Because most of the good ones, the good names, commonly used names, they're all taken, right? So you first have to check if it's available. And if it is available, you can then check out, and like a regular shopping cart, you can check out and make the payment, right? So then the domain is registered for you, all right? So that's one bit. We'll also look at health checks, right? So we'll look at health checks later because we have to set up a health check as part of this demonstration. All right. Now the other thing is, once you register a domain, you'll find that a hosted zone is created for you automatically, right? So let's go into hosted zone. You can see there are two zones here, right? These are two domains that I own, right? Now you can, once you register a domain, a hosted zone will be created automatically for you, right? You can see the second one here. This one was this domain was registered within Route 53, so the hosted zone was created automatically, right? But the first zone was actually registered elsewhere, and then I had to sort of manually create a hosted zone in Route 53. Right? You can do that by clicking on this button, right? So just type your domain and then say create. That's it, right? But the domain should be registered, right? You should have already registered the domain. All right. Now, once you create a hosted zone, let's assume that it's been created elsewhere, right? It's an existing domain which you had registered elsewhere. Now you want to use Route 53. So what you should do is first create a hosted zone like this, right? And then you'll have a record like this one created. So when you click on this, right, what you'll find is you'll find two records created for you automatically. One is this one, the name server type, okay, the NS type, the name server type. This will be created automatically for you, all right. And then the second one that will be created automatically for you is this one, SOA, start of authority. Okay, so these are DNS terms, right, and standard DNS stuff. So you can nothing to do with AWS, right? These are standard DNS concepts and terms. Okay, so these two records will be created automatically for you, and then you can go ahead and create other records like this is an A type record. MX is basically for your email servers, right? So these things you can do yourself, but name server and SOA records will be created automatically for you if you have registered the domain in Route 53. All right. Okay. Now, even if you have not registered the domain, what you do is you create a hosted zone like this, and you will still have these two records created for you, right? And to make the whole thing work, right? Remember, if the domain has been registered elsewhere, let's say in GoDaddy, right? And now you want to use Route 53 for DNS management, you need to tell GoDaddy that, look, stop managing the records in your servers, right? I'm going to manage it myself. Okay. So what you have to do is, you have to set up these 4 name servers, right? The 4 name servers that you see in this record, right? You can see here as well, these 4 name servers. You have to set them up in GoDaddy, GoDaddy.com's portal. Okay. So there'll be, you'll find a way in which you can say, look, I'm managing it myself, right? I don't want you to manage my record sets. So here are my name servers. So you have to basically set up these 4 name servers in GoDaddy.com's portal, right? Once you do that, it takes a few minutes. Then you can start using Route 53. Okay. So if a domain is registered here, you don't have to do anything. It works quite smoothly, right? If a domain has been registered elsewhere, like in GoDaddy, then you have to use Route 53. You have to set up these 4 name servers in that portal. All right. Okay. That's how you do the setup. All right. Now let's talk about our DNS failover. Right now, what we want to do is we want to set up this one. Right. So we want to create a DNS failover set of records, one pointing to the primary site, the other pointing to the secondary site. Okay. So let's see how to set that. Okay. So first, what we'll do is we'll create our first record. We have to create a pair of records. Okay. So this is our domain name, right? This is our domain name. And we want to point this to our primary site, right? So we can paste our public IP address. You should be using an elastic IP, not a public IP normally, okay? But for now, it will do. And in the routing policy, you select failover. All right, you say failover as the routing policy. All right, and also make sure that you specify the record type correctly. This one is the primary type, so this is fine. No need for change. All right. Okay. Also, you need a health check. Okay, you need a health check to be associated with this record, because the health check is the one that tries to figure out whether the primary is up or down, right? And if the primary is down, then the failover will happen based on this health check. Okay, so for the moment, let's not create this record. Let's go out to health check, right, and create a health check first. Okay, so this one is an older one. Let me delete this and show this to you from the beginning. Okay, so let's create a health check, right? And this is very similar to the load balancer's health check, right? So let's say this is, let's give it a name here, and you can specify the IP address. Remember again to use the elastic IP address normally, all right? And also you can do some advanced configuration. So I'm just making the checks faster so that we don't have to wait too much. Okay, so it checks the health. And if it doesn't receive a response 3 times in a row, let me reduce this as well, then it is considered unhealthy. All right. So this is a health check, very simple. Let's set this up. All right. So now the health check is set up, right? It says unknown, the status is unknown, but soon it will show healthy, right? It will show a status of healthy because we know our site is up. Okay. All right. So this is our health check. Now going back. Let's create our DNS failover records. Right? So let me go back into my hosted zone and create my the first of the 2 records. Right? So this is the domain, all right, and we pointed to our primary site, which is the public IP address of our site. Routing policy is failover. Failover record type is primary, right? And then yes, we do have a health check because we need a health check here, right? And we select our health check. Okay, so this is our first record. Okay, now this alone is not enough. Okay, we also need a second record pointing to the secondary site, right? So let's create that one now. So the domain will be the same, okay, because it's the same site, right? So you have to create the second record with the same domain name. All right. Now this one will be pointing to our S3 bucket, right? So we use the alias record type and point this to our S3 website. All right. Routing policy will be the same. Failover. The record type will be secondary. Okay, it's important. It will be secondary, and there's no need for health check, right? Because basically we want to failover from the primary to the secondary, right? You can have a health check, but not necessary. All right. So this is what we've done. This is a second record with the same domain name, but this time pointing to our secondary site, which is an S3 static website. All right. Okay. Let me create this one. Right. Let me create this record as well. And now we have two record sets. Right. One primary. This one. This one is the primary record set, and then this one is the secondary record set. All right. Okay. So we're done, right? We're done. Now let's test this site. So let me go to the domain name, right? Let me go to the domain name, and you can see the site response, and you can see that it's the primary site, right? The EC2 instance which is responding. Okay. So you can try this. Let me share this with you. Let me share this link with you, and you can try this from your browser as well. All right. Now, what we want to see is the primary site is working, but will the failover happen? Right. That's what we want to check. So what I'm going to do is to simulate a failure on the primary site, I'm going to stop this EC2 instance, right? And then we'll see if the failover happens. All right. So let me go and stop this EC2 instance. All right, and this will take a bit of time because it's a graceful stop. It takes a bit of time, but soon, you know, the health check, right? We have a health check here. The health check should figure out, right? The health check has to figure out that the site is down. Right now it says healthy. Right now it thinks it is healthy, right? But very soon it'll figure out that the primary site is down, right? As soon as that happens, it should fail over. Route 53 should fail over to the secondary site, right? So let's just wait for this. Let's just wait for this, and as soon as it becomes unhealthy, we'll then try our domain name once again, and this time it should be pointing to our secondary site. All right, so okay, any moment now, right? Any moment now. It's been a while. Let's see. Okay, so now you can see it is in an unhealthy state, right? So it has figured out that the primary site is down, right? So immediately, if you go and check your website now, right, it should fail over. You can now see that it is pointing to the secondary site, getting a clear message from the S3 bucket saying, you know, it's a S3 bucket, and we hope to be back soon. Okay, so this was a demonstration of the DNS failover, right? How do you set it up? Basically, you have to set up two record sets, one for the primary, one for the secondary, and the primary should have a health check associated with it. Okay, the other routing mechanisms like geolocation or a weighted round robin or latency-based routing all can be set up with the same steps. Okay, in all these cases, you need to have two record sets, right, pointing appropriately to the appropriate stack. All right. Okay. So this concludes our demonstration on Route 53. Let me stop here. Let's see if you have any questions on this service. All right. Okay. So let's look at these questions. Chandra, course project. This is in the LMS, right? Just go to I think edureka.co, right? And sign in, right? You'll find in your course uh, the last section. Right? The last section is the course project. All right. Let me know. You can try it now. Let me know if you don't find it. Or you can also write to support if you need help with finding that document. Okay, it's in the LMS in your course. All right, Rao, what is the difference between DNS resolver and Route 53? No, so what happens with DNS is you have DNS maintained. DNS records are maintained, can be maintained at different levels, right? So they are cached. They can be cached in your own network, right? In your corporate network, at your ISP side, right? So the resolver basically responds, right? So resolver can be like a cache server which has details of your domain, right? And when the user goes to that domain, the resolver can respond if it has it, right? But the Route 53 is what is called the authoritative DNS service. It's a final authority, okay? Route 53 is the final authority. This is where the domain, the actual real records as specified by the domain owner are specified, right? So this is the authoritative authority or authoritative server, right? So this is the final authority, let's say. Okay, that's what it means. So so when you make changes, when you create new records, or when you make changes to your records, Route 53 is the one that knows, right? And the resolver may have stale data, right? It may have stale data, but the point of the resolver is that it can respond faster, right? Because it is local. Okay, so resolver plays an important role in that it can cache and respond faster. So it's good from a performance point of view. Okay, all right. Rao, domain configuration, for example, on GoDaddy, can we do it ourselves or do we need to call GoDaddy? Domain configuration, for example, on GoDaddy. No need for call. These companies don't want you to call, right? Look, all companies, right? All companies want full automation, right? So that they don't have to spend on things like customer service. So you don't have to speak to them. Right? You don't have to speak to them. You can do it yourself. You can set up the name servers, right? You have to set up the 4 name servers, 4 Route 53 name servers, right? On GoDaddy yourself. Okay, you'll find it easily. Basically, you have to basically you're saying, look, I want to manage it myself, right? And here are my name servers. And then GoDaddy will stop managing your record sets and will let Route 53 manage your record sets. All right, Valen, if it's possible to exchange the registered domain in one AWS account to another AWS account. I don't know. You can, in general, right? You can transfer. Look, I don't know if you can transfer from one AWS account to another, but in general, right? In general, domains can be transferred. Well, you can try AWS support. Okay, maybe you can contact AWS support to see what they say. Right? They may have to update some things on their backend. I don't think it's available from the AWS console. Right? You can't transfer from your console, but maybe support has some tools that they can do something like this. Okay, but it's not. It's something. This is something that's not a common request. Okay, it's not a common request, so I doubt that they will have this. You can try it, right? Okay. Also, question is why do you want to do it? Okay, why do you want to do it? You can also do another thing. You can, in general, you can transfer a domain to someone else, right? So that someone else can be the other AWS account. Okay, so this is common because you may want to buy a domain, right? So you can buy a domain from someone else. So You can transfer a domain to someone else, but the procedure here will be more tricky. Again, you should contact the AWS support. All right, okay. Valen, if I have removed the default record in DNS, what happens? How to recover? Which one? Which default? Let me know which record you're talking about. Okay, so I'll come back to that. Renju, if we have a multi-region website, can we configure Route 53 to serve the request record from the nearest region? Yeah. So that's what latency-based routing is, right? Latency-based routing. Latency-based routing is the same thing. It's the same thing, right? So yes, definitely you can do something like this. All right. So it'll serve content from the nearest region for that user, right? Different users may be served from different regions based on where they are from, right? So US user will be served from the US region. Asia user will be served from the Asia region, right? So that's how it works. All right, this one, if you remove the NS record, how to recover? Maybe what you can do, right, is maybe you can try and create the hosted zone yours once again, right? So if you deleted the main record, let's say let's say you've deleted everything, right, and you've also deleted the name server. So so what you can do is maybe you can delete the hosted zone, right? You can delete the hosted zone and recreate it. Okay, so then when you create the hosted zone again, right? So you can always delete a hosted zone, right? Just delete this hosted zone and then create it again. Then again the name server should come up. All right. Okay. So hopefully that'll be fine. So delete and create hosted zone again, because I know that when you create a hosted zone, the name server record is created. Okay. So I think deleting and creating should solve this. Okay, how to contact AWS support? I tried to get a call. No, you have to write to them. Okay, you have to create a support ticket. Okay, you have to create a support ticket. Basically, you can see here, support, right? You can see on the right side, support center, right? Support center, and then you can write to them. So you can create a case like this, right? Create a case like this and write it. Okay. All right. So I don't look. Depends on the support plan as well, right? Like I have a plan which is basic. I don't pay anything for this, right? So there's no phone number. Nobody's going to pick up your phone because it costs a lot, right? So it depends on your support plan. In general, you can raise. This is better. Okay, this kind of case is better because then they can respond in their own time. All right, Gajendra, you bought a domain for 2 years at around 53 for $22. Will there be an additional hosting cost as well? Yeah. So there will be, a host. It's like $50 per month, $50 per month for a hosted zone. Okay, so that's additional. Yes, that is additional because $22 is the registration cost, and this is the cost for sort of maintaining your record sets. Okay, so that's there. All right. Is it possible to back up the Route 53 configuration? Yeah, no, from here I don't see any way to do it. Right, it's a good idea because I think Valen also said that you might delete some of these records, right? So so it doesn't look like you have anything here. Right? It doesn't look like anything is available here. It would be a good idea to have that though. Yeah, so I don't see any option here. Right, I don't see any option here. Yeah, but look, usually what happens is these are a small number of records, right? You can manually store them as well if required. Okay, and most of the information here, like say your mail servers, all this this is Gmail mail servers, right? You can get this from elsewhere if you lose this record. Usually you'll know the IP addresses to which you want to point your domains, right? So usually it's not a problem. Right? Even if you delete something, usually it's not a big deal. It's not a lot of data that we lose, so it should be fine. So here I think you'll have to do something manually, right? That's all that is possible. Okay, all right. Okay, folks. So now let's move on, right? Let's move on. We are a little bit short of time. Let's move on. Let's look at the other topics for today. All right. So next is management tools. Okay, next is management tools, and what we'll do is we'll look at 4 management tools in this module, right? And like I said before, management tools are required, right? They're not as important, say, as EC2, but they are required because without these you won't be effective, right? You can't really use AWS effectively. And especially for live environments, these are important. Especially when you have some complexity in your organization, right? If you're a larger company, you have a larger team, many people using it, right? Then these kinds of things become more important. Okay, so we look at 4, right? CloudTrail, CloudWatch, CloudFormation, and Trusted Advisor. There's a typo here. It should be Trusted Advisor. Okay, so let's first talk about what each of these are, right? And then we'll start looking at these one by one. Okay, so CloudTrail is actually, it's an audit trail. It's an audit trail, right? So this actually should be seen along with IAM, Identity and Access Management, right? Which we are looking at in Module 9. So in Module 9, when we look at IAM, we learn that IAM is where you can create your AWS users, right? Your IAM users. Basically, these will be people in your team, right? Let's say you have 10 developers, 5 system administrators, 2 DBAs, right? So for each person, you have to create an IAM user, right? And then you'll assign permissions. You decide what each person can do and not do, right? So that is created in IAM. In addition, your applications and your scripts, right, will also need permissions, right? So you may have to create users for those kinds of things as well, right? So you'll have users basically with permissions created using IAM, right? Now you also want to know what each person is doing. Okay, so for example, in a bank, right, it varies by industry, but in a bank, now I have worked in a large bank, and in a bank, what happens is everything has to have an audit trail, right? Everything. So when you log in the morning to your computer, that is logged, right? Who's logging in at what time, right? That has to be logged. If you and any kind of activity, right? You may have many applications, you may have many networks. So whatever a person does in a bank is actually logged, right? So that things like what date, what time, what was the action, what was the object or resource that was accessed, right? So those kinds of things are logged. That's a very important thing for banks because you can proactively look at your logs to see if something wrong is happening, right? Some kind of external attack, some kind of internal attack, because banks are susceptible both from outside and from inside, right? There have been cases where employees are doing something, right? Of course, they're always under attack from external attackers. Okay, so audit trail is a very important part to sort of see what's happening, right? And of course, post facto also, right? If something goes wrong, let's say there's a major hacking attack, right? Some money was stolen, right? So then you have to go to the audit trail to see who did what at what time, right? If the authorities need to get involved, the police, and so on. So the audit trail becomes a very important asset, right? For these types of requirements. So that's what CloudTrail is. It's an audit trail. It captures every action that any of your users, right? The user could be a script or an application, or it could be a person, right? So all those things are captured in a log, right? And that's available to you. Okay, that's it. That's what CloudTrail is. All right, CloudWatch is very important, right? All these are important, but CloudWatch is extremely important, very commonly used as well. And this is basically a monitoring tool. Okay, so it can monitor many things actually, and it usually has 7 to 8 metrics for each type of resource, right? So EC2 instances, it has data on 7 or 8 things like CPU utilization, network, incoming network size, network amount of data that is flowing, right? Stuff like that. So for each type of resource, EC2 instance, RDS instance, EBS volumes, S3 buckets, right? All the various types of resources CloudWatch will have a certain set of metrics that it will monitor for that type of resource, right? And it monitors data at an individual resource level, individual server level. You can also aggregate data, compare data across different dimensions. So, for example, you can look at the CPU for the entire auto scaling group, right? Or the CPU for an individual server in the auto scaling group, right? So that kind of aggregation is also possible. Okay, so that's what it does, and then this data is actually collected over time, right? And then you can do some analysis. You can look at trends. You can do some charting, right? The data can also be used for creating notifications. CPU too high, server is down, right? Those kinds of notifications. So lots of benefits from this data. Okay, this data can be used for decision making around things like capacity planning, performance management, etc. Okay, so very important service, extremely important. Okay, CloudFormation is a very powerful tool. Okay, it's a very powerful tool because what it does is it can automate the creation of your infrastructure. Okay, the mantra of CloudFormation is infrastructure as code. Okay, infrastructure as code. You might have heard of configuration as code, right? Which is what Chef and Puppet do. Okay, where you're always installing Apache, you're deploying your application, you're doing some configuration again and again and again, right? So why not automate that? So that's configuration as code, right? Which is what tools like Chef do. So CloudFormation is actually infrastructure as code, where let's say you're creating environments, right? You have to create a test environment today, a performance testing environment tomorrow, a TR site tomorrow, a day after, right? So you have to create environments again and again and again, right? And you may have many applications, right? A bank, for example, has literally thousands of applications, right? Each application may have its own development lifecycle. So system administrators have to create various environments, right? Day in and day out, you're creating environments all the time. So with CloudFormation, you can automate all that, right? So instead of creating a stack, right, and this could be a complex stack. You have load balancers, you have VPCs, you have auto scaling groups, right? Instead of creating that manually, which takes up a lot of time, is error prone, right? Just create a template, okay, which has information about your stack, and give that template to CloudFormation. CloudFormation will create your stack for you, fully automated, right? So it's like an army. Army is for a server, right? CloudFormation template is for a whole stack, no matter how complex it is, right? So you basically have an army-like thing for a complete stack, and you can use that template again and again and again, right? So it saves you a lot of effort. It prevents errors. It helps you move faster. Okay, very powerful tool. All right, and finally we have Trusted Advisor. This is basically like a advisor, and it tells you when you're not complying with best practices. Okay, if you're not following best practices, it will warn you. It will tell you, for example, that you have unrestricted access on port 22. Okay, so it can tell you those kinds of things. It will warn you that, look, boss, you're doing something wrong here. You're increasing the risk, right? And it advises on things like security, cost optimization, fault tolerance, and so on. All right, so that's Trusted Advisor. Very important tools. Okay, very useful tools as well. And these are not all the management tools. There are other tools also. We can't see all of it, okay, given the time, but we're looking at 4 of these tools. All right, so let's start with the first one, right? Let's start with the first one. Let's look at CloudTrail. Okay, nothing much, right? Just one slide. Basically, what happens is all the, in IAM, you have to create your users, right? We'll see IAM later. But, you have, say, developers, system administrators, you have some applications, all these people and applications and scripts will have a user, right? The user will have permissions. And based on those permissions, the users will, act, right? So they may, a system admin may create an EC2 instance, for example, right? An application may access a DynamoDB table, right? So all those things are happening, okay, from your company's AWS account, right? And all those activities are logged in a log file, right? And that log file is called that service is called CloudTrail. Okay, All right, that's basically it. It has some other additional features, like you can have receive some notification, right? You can save the log files into an S3 bucket for safe storage, right? Long-term storage. So all those things are there. But broadly, right, the big picture is it's an audit trail. It's a log of every request made to your AWS account by all the users that you may have. All right. Okay. Let me show this to you so that you get a better sense of what it is. Okay, so Cloud Trail, right? This is management tools, and if you look at Cloud Trail, you can now see. Yeah, so this is my, in my account, right? So this is just a demo account, so I just use the root user, right, the master user. So you don't see too many users here. Hopefully, okay, you're not seeing too many users, only root. Okay, but normally you'll have many users, right? A normal team, say developer one, system admin one, right? All these, you'll see activity by all the users, right? And then you can see, that there are various kinds of activities. So there's a stop instance activity, right? It tells you which resource. In fact, if you look at the detail of this record, right, it has some interesting information. So one is it has the date and time. Right? This alone is very important, okay? Because you might have seen in security, right? Even when you sort of go into your office, right? Either you have a paper-based trail of who's entering, what time, right? You have to write what was the time, you have to sign, right? Or you may have an automated system where you have a thumb, like a fingerprint-based entry system. So all that is, the whole reason is to find out who's entering at what time, right? Because then that can be used to sort of trace what exactly happened, right? That's what is happening here. It's all digital, but here you can see, this is there's a date and a timestamp, right? Next, you have the username. Who's the user? Right? This is the reason why for every person in your team, you must have an individual account, right? You should not share IDs, because this way you can identify each person's actions, right? Then you have the action, the event. So this was a stop instance that we did, right, for the DNS failover case. It also tells you what resource and the specific server that was stopped, right? And then other information like region and so on. All right. One more important piece of information is the source IP address, right? This is the IP address from which this action was initiated, right? This can be very important. For example, if it's an external IP address, right, or even if it is internal, the IP address will tell you where this person was, right? For example, if it's an external IP address, the police, let's say it's a police case, right? The police will go to the internet service provider. The internet service provider has to quickly, right? This is, when the government licenses an internet service provider, these are the things that they sign up for, right? They're obliged to provide details about this IP address. So the ISP will tell the police, look, this IP address was issued to so-and-so person. Here's the address, right? Then the police can make a visit, right? So the source IP address is a very important field, in addition to date, timestamp, and username, right, in the audit trail. All right, okay, that's it. That's all you need to know. It's a very, very important tool from a security perspective. All right, let's look at another one, right? Let's look at another one, and this one is Trusted Advisor. Okay, so this is Trusted Advisor, right? And what this does is it advises, right? Now let me give you an example. So in my experience, in a bank, right? I used to work in a large bank, and what we used to have is we used to have an annual audit process, right? Annual audit. So this would be typically an external person, right? Not from our team, not from our business. In our case, it used to be a person from the company, but from some other region, right? So if you were in India, the person would come from, say, Singapore, right, or from the US. And so this person is someone we don't know, right? But so it's independent to that extent. And usually the auditor is an experienced person. They've seen a lot of, they have a lot of years behind them, right? And they have expertise in technology, right? And also, practices and compliance and things like that. So the auditor comes once a year, and they will ask for things like, show me your processes, right? Show me your documentation, show me your systems. How do you do certain things like change management, problem management, right? How do you do incident management? So those kinds of things they will ask for information, right? And they will interview people. We are obliged, right, to provide all the information, to cooperate with them. So we do all that, and so they will study all this, and then they write a report, right? So the auditor will write a report saying, either fantastic job, right, no problems found, but usually it's not like that. Usually they will identify a set of issues, right? And the issues will be basically, this area is weak, right? You may be running a risk here, right? So they'll identify a list of issues, and the issues are usually prioritized, right? So they will say, look, these 10 issues are very serious, right? You must fix them in the next 3 months, right? The next 20 issues are medium. You should fix them in the next 1 year, right? And then you have a big bunch of nice to haves which you can fix in a reasonable time, right? So this is the kind of report that they would write. Of course, they'll give you all the details, and they also give you recommendations, right? So they'll say, look, this is the problem. It's a serious issue. You should fix it quickly, and here's how we suggest you go about it, right? So that's what used to happen in the bank, right? And I think it's a very useful process, right? It's a very useful process. Most banks do it, right? And also in other industries as well, something like this happens, right? It's a useful process to proactively, test your practices and your systems and your training, right? And this is a good thing. Okay. Now this one, trusted advisor, is something similar. Okay, it's like an auditor, and it checks your setup, right? It sees what security groups, because it has all your data, right? You're basically setting up all this in AWS. AWS has all your data, so it knows your security groups, for example. It knows your routing rules in the VPC, right? It knows which ones are public subnets, which ones are private subnets. It knows whether you're taking snapshots of your EBS volumes, RTS instances, right? So it knows all that. Okay, so it doesn't have to collect any information from you because it already knows all your information, right? And then what it does is it has a database of best practices, right? And so it compares your setup to its database of best practices and is able to generate a list of issues, right? Very similar to the auditor's report. The issues are basically, look, you're not taking snapshots, right? Which means if your database fails, then your data will be lost, right? So it'll raise issues. It will prioritize those issues. There's the green, orange, and red, right? So it's basically a severity that it assigns, right? And also it gives you recommended actions, how to fix that issue. Okay, so it's the same thing. It's the same thing as an auditor, except it's not a real person. It's an automated tool, right? Also, the trusted advisor is not a once-in-a-year exercise, right? It's an ongoing exercise. You can go every day and check the recommendations from the trusted advisor, right? So you may be a big team, for example, lots of people doing lots of things, right? So every day someone does something which may increase increase the risk to your system, right? So if you have a very active set of users, you have a very active set of things happening in your infrastructure side, right? Every action can create some risk. So you can actually go into trusted advisor every day to see, if something has changed, right? So it's not an annual exercise. It becomes a daily exercise, or whatever frequency that you want to use it at, right? So in that sense, this is even better than the annual audit process that banks have. Okay. So that's what a trusted advisor is. Let's take a look. Okay, now one more thing is the trusted advisor is actually, it's only available to certain accounts, right? Paid accounts. Okay, it's not available for free for the basic account that we all have, right? I have a basic account. It's a free account. I don't pay a monthly fee for support. Okay, so then this is not available, right? So it's not available to such an account, but you can still see what's going on. All right, so you can see here, this is the dashboard here. It actually has checks in 4 categories, right? So there's cost, performance, security, and fault tolerance, right? So there are 4 categories, and then there's a bunch of checks in each category, right? So for example, if you look at security, right? If you look at security, you can see there's one issue with the red flag here, right? So basically it's saying, look, you have unrestricted access on certain firewalls, on certain security groups, right? And that too on sensitive ports like port 22. Okay, that's what it is saying. So it's a serious issue. It's red, right? It's marked in red, and it also gives you recommended action. So it tells you exactly what firewall we are talking about, right? So it says, look, in this region, this is the name of the firewall where you have, unrestricted access. All right. So you can easily go and find out what's going wrong. You can go and fix that. Okay. So this is the kind of check that the security advisor, the trust advisor has. All right. Let's take a look at a couple of examples, right? In cost, for example, cost optimization. All right. Now you'll see that these checks are all grayed out, right? They are grayed out because I don't have a paid account. Okay, but I can still see what it does, right? It's not active, but I can see what it is. So now, for example, under cost, you can have a check like this one. Unassociated elastic IP addresses, right? So a lot of people don't know that if the elastic IP address is not associated to a server, then there is a cost there, right? Normally it's free, but if you don't use it, right, if you don't associate it to a server, there'll be a cost, right? A lot of people don't know that. So this is good, right? Because it can, especially when you're new to AWS, or if you're a big company, lots of new people come, right? New system administrators, new developers, they all don't know all these things, right? So that's why this can be useful. It can tell you, look, you have these elastic IP addresses which are not being used, right? You're paying unnecessarily. Either you associate them or you release them back to the pool. Okay, all right. Another check under cost is reserved instances optimization, right? This is a very important thing. It can save you tons of money because reserved instances can be 60% cheaper than on-demand instances, right? So this check will, analyze your EC2 instance usage, and then it can make some recommendations around how you can use reserved instances. Okay, so these are just two checks, but other checks are useful as well. And then you can look at other categories like performance, right? On performance, for example, you may not know, a lot of people may not know that if you have too many rules in your security group, right, that will lead to a performance problem. All right, because remember, the security group has to check each packet, right? Each packet that goes in or out of the EC2 instance has to be checked to see if it follows the rules, right? So if you have too many rules, then each packet has to be checked against each rule, right? So that can cause a performance problem. That's not normally known to people, right? So this will be a very good check. All right. What will commonly happen though on performance is you may have this, right? High utilization EC2 instances, right? EC2 instances which are too small for the workload, right? So your CPU is too high, maybe it's 90% or more, right? So that's very common, right? So you have to then go and either increase your auto scaling group desired capacity, right? Have more servers, right? Or in some cases you may have to do vertical scaling where you may need to have bigger servers. All right, all these things it'll check and it'll keep highlighting, right? Not just once a year, but on an ongoing basis. Okay, so that's what Trusted Advisor is. All right. Now, one more topic, right? One more topic, and then we'll stop for Q&A. We'll do CloudFormation on Monday. All right. Okay. So let's talk about the next topic. This is CloudWatch. Okay, CloudWatch is a very, very important service, right? Among all these, all are important, but CloudWatch especially is very commonly used. Okay, it is commonly used, no matter who you are, large, small, whoever you are, right? You have to use CloudWatch, okay, because it has many applications. So first of all, what does it do, right? What it does is it captures data, right, or metrics about your AWS resources. Okay, so for example, if you have an EC2 instance, CloudWatch will collect automatically the CPU utilization, right, or network flow, in, network out, right, how much of data is flowing in, how much of data is flowing out, those kinds of things, right? So it has a bunch of metrics for each type of resource. So EBS will have its own set of metrics. S3 will have its own set of metrics, right? So it captures metrics automatically, right? And it does so at a frequency of every 5 minutes, right? You can increase that. You can have detail monitoring, which is a paid service, right? Basic monitoring is free. Detail monitoring is has a slight cost, small cost, but with detail monitoring, the data is collected more frequently every minute. Okay, so all these metrics data is being collected over time, right? So it's time series data. All right. So once you have time series data, you can then chart it, right? You can do analytics on it, right? And that gives you lots of you can interpret the data and take some decisions. For example, cost related decisions, capacity planning decisions. Sometimes it is useful for troubleshooting as well, right? So that's one benefit, right? So you have data, and then you can look at the statistics and you can take some decisions. All right. The other benefit of the CloudWatch metrics is based on the metrics, you can create alarms and receive notifications, right? So for example, if CPU is too high, you may want to know, right? You should know when the CPU is too high. So you can create an alarm using the CPU metric, right? If CPU is too high, above 90% for 5 minutes, send me a message, right? So you receive a message using via SNS, simple notification service. This is another service which we'll talk about later in the next module, right? But this is what is called a pub sub service, and the CloudWatch can publish a message, and all the subscribers to that topic will receive a communication, right? Either via email or SMS or push notification. So that's a separate service, but CloudWatch is integrated with SNS, and this way you can be notified about every tiny aspect of your infrastructure. All right, so that's another benefit of CloudWatch. All right, by the way, CloudWatch data is also used in auto scaling, right? Auto scaling is something we saw yesterday, where if CPU is too high, add more servers, right? So that automated scale out or scale in that happens is actually based upon CloudWatch data. All right, okay. All right, so this is what CloudWatch does. It collects data in a time series and then makes it available for analysis, for charting, for alarms and notifications, and for auto scaling, right? So at a high level, this is what CloudWatch is. However, you should also know that CloudWatch data is limited, okay? Because, for example, with EC2 instances, CloudWatch has visibility at the hypervisor level, right? Hypervisor is the virtualization layer. So it only knows certain types of information. So it knows CPU, but it does not know memory utilization. Okay, it has no idea about your RAM, how much is the RAM available, how much is being used, right? It also doesn't know about the disk. Okay, it doesn't know how much of your disk has been used up, what is the swap usage. So all those things are not known to it, because those types of metrics are available at the operating system level, right? Operating system. So operating system has its own domain, right? And CloudWatch does not have permissions into the operating system, so it doesn't know that. Okay, so the CloudWatch metrics are limited to the hypervisor visible layer. All right, so that's very important to know. Okay, but so how do we get that data? So how you get that data, like memory or disk utilization, is by writing some scripts. Okay, and you don't have to write it. AWS gives you that. So you can basically, you have some scripts, Perl scripts, or you have some agents which you can run in your servers. All right, and these agents will push the data into CloudWatch. All right, so that's important to know. By default, right, CloudWatch out of the box has a set of metrics at a hypervisor level, right? You can complement that. You can add to those metrics by setting up agents or scripts in your servers to push data. Okay, you can push anything, memory, disk, log files, right? Log files, also many different types of log files can be streamed into CloudWatch. So you have application log files, syslog files, database log files, web server log files, right? All those things can be streamed into CloudWatch, and then you can create more metrics out of those log files. Okay, and one last thing, right? You may have a hybrid infrastructure, right? And you don't want a different monitoring tool for your on-premises servers and a different monitoring tool for your cloud servers, right? So that's why CloudWatch lets you push data even from your own servers. Okay, so you may have on-premises servers. You can push data from there into CloudWatch, and this way you have a single place, right? CloudWatch becomes your single place where you can monitor all types of infrastructure, not just cloud ones. Okay, all right. So that's what CloudWatch is. Let's take a look. Okay, so under management tools, you have CloudWatch, right? You have CloudWatch, and this is the CloudWatch dashboard, right? You can do lots of things here. All right, you can do lots of things here. For example, you can look at metrics, right? You can look at metrics of EC2, for example. All right, you can look at metrics like this one. All right, so these are all old servers. They're all deleted, so you don't have data. So this is a dashboard from where, so this can become your single place where you can monitor all types of resources. All right, let's leave this for the moment. I'm going to show you CloudWatch data for a particular server. Okay, so you can look at CloudWatch from the CloudWatch dashboard, or you can also look at CloudWatch data at a resource level. Okay, so in Singapore, I've just changed to Singapore region. So in this region, I have a server, all right, which has been running for a while. It's like a production server, a small application. All right, so let's take a look at this because we have real data. Okay, we have real data for a real server. So this is our server, right? And if you go to the monitoring tab, okay, you will see the CloudWatch metrics. All right, this is CloudWatch metrics, and this kind of monitoring tab will be available for all types of resources, right? EC2, EBS, S3, RDS, Redshift, Elasticache, right? So any service, all services are monitored by CloudWatch automatically and free of cost, by the way. All right, free of cost in the sense, the cost that you pay for the server covers the cost of CloudWatch, right? You can turn on detailed monitoring. This collects data faster at a faster frequency, and this has some cost. All right, the basic monitoring is free. Okay, so this is CloudWatch data. Now, if you look at this set of metrics here, right, you have things like CPU, you have a network, right? You have status check also. This is the same health check that is used in auto scaling to replace unhealthy instances. All right, so you have all these metrics, and you'll notice the disk metrics are all flat, right? This is because this refers to the non-EBS instant store type of devices. Okay, so which are not being used on this server. That's why they are flat. Okay, now you'll notice there's no RAM, there's no memory metric, right? There's also no disk. These are different disks. Okay, there's no information about how the EBS volume is being used, right? No information of that sort. So that's why these metrics are only hypervisor visible metrics, right? They're not a complete set of metrics. All right, okay, but let's take a look at one of these metrics to see how you can analyze CloudWatch data. All right, so let me click on this one, CPU utilization, right? And you can see here it shows you a chart, right? Shows you a chart, and it's a time series chart, right? So this is at 1545, 1550, 1555. So it's a 5-minute interval, right? You can make it better by enabling detailed monitoring, and then you have a 1-minute interval, right? So you have more granular data. All right, so you can, CloudWatch also, by the way, collects data and keeps data for only 2 weeks. All right, that's very important to know. Only 2 weeks is the retention period of this data. Okay, you can store it for longer by taking the data and keeping it yourself, maybe in S3 or something like that. Okay, so it's possible to store for longer, but by default, right, out of the box, CloudWatch only stores for 2 weeks. Let's expand the horizon to 2 weeks, right? So now you can see the chart has changed, right? So I'm trying to show you basically what I'm trying to show you here is CloudWatch data has to be looked at, has to be charted, right? Has to be interpreted, right? And then you can take some decisions, right? So that's what I'm trying to explain to you here. So here this is your EC2 instance and the CPU over a 2-week period, right? And someone in your teams has to do this, right? They have to look at this data and see what has to be done, right? So for example, as soon as you look at this picture here, by the way, this is average CPU, right? This is average CPU over a 5-minute interval, right? That's what it means. If you have 1-minute interval, you can look at average CPU over a 1-minute interval as well, right? Okay, by the way, if you increase the period to say 1 hour, you will see a smoother curve, right? This is also very interesting. When you change the period, it gives you different perspectives. It gives you different perspectives on your data. So you can change the time range, you can change the period, you can also change the statistics sometime. So, not all statistics make sense all the time, but it depends on the context. For example, sum of CPU doesn't make sense, right? It has no value, right? It has no value. But maybe maximum CPU makes sense, right? Maximum CPU may make sense. Okay, but average is the best one, right? Average statistic is the best one, and you can play around with the period, with the time range, right? Let's look at the 5-minute time range, right? This is the chart you get. So so you have to interpret this, right? So first of all, what I would do here is I would be wondering what this is, right? We seem to have spikes, sometimes reaching up to 100%. So if you don't know what it is, you should definitely be looking at it, right? So this can point out some problem with your application or your infrastructure, right? So this is something to check out. Now I know what it is, right? It is basically a batch job that runs at something like 4 a.m. in the morning. Okay, so I know this. I've checked it out. It's fine, right? So as long as you've checked it out, it's fine. That's fine, right? So this is something that you may notice. Okay, what else, right? What else? So what else is you can maybe if you change the period, right? If you change the period a bit, let's say to 1 hour, right? You get a smoother curve, all right? And this gives you some idea of what the average CPU is. Right? You can see the average CPU is probably around 15%, right? 15% is the CPU. Okay, so what does that tell you? Right? What that tells you is that your server is actually over provisioned, right? The server is too big. Okay, you might be losing money. You may be wasting money because your server is not being used much, right? So you can then think about changing the capacity, lowering your capacity, right? Either lower your server size or reduce the number of servers you have in your auto scaling group. All right. Okay. So this is how you can, this data is very valuable, right? It tells you what's going on with your server and what you can do next, right? So in this case, I would reduce the capacity, right? If the CPU was too high, something like 50, 60, 70% on the average, then I would say you are under provisioned, right? You have to add capacity. All right. Same thing with the trend. If your trend is increasing, right? If the CPU keeps going up, that could point to some kind of problem with your application, maybe some kind of memory leak, right? Or it's a good kind of problem where your users are increasing, usage is increasing, right? But in any case, you have to take care of the capacity, right? Otherwise, your infrastructure will crash. So you need to add more servers or maybe create an auto scaling group which can scale automatically, right? So those kinds of decisions can be taken just by looking at the charts. All right. Okay. So this is how CloudWatch works. All right. You can let's also look at the EBS volume, right? So if you look at the EBS volume here, okay. So the EBS volume is a different type of resource, right? So it has its own set of metrics. So here you can see there's bandwidth information, throughput information. Throughput is how much of data is transferred per second, right? Then you have queue length, which is how many transactions are waiting to be processed on the disk, right? You have latency type of metrics as well. So these metrics actually are very, very useful, especially when it comes to performance tuning, right? Let's say you're running MongoDB, Cassandra, Oracle, SQL Server, right? Sometimes Hadoop as well, but mainly, if you have a transaction database, right? And if you're worried about performance, if your users are complaining about performance, right? Then one of the places you will look at is these metrics, right? The EBS metrics, because EBS can be a bottleneck, right? EBS may be causing the problem. Okay, so you have to come to these metrics and take a look. So, for example, let's say let's take one of these, right? Let's take queue length. Okay, so queue length is how many transactions are pending, are waiting to be completed, right? Waiting to be processed. Okay, so you can see here sometimes these are concerning, right? This is high, 3.5 is high, 4.5 is high, and these are those batch processes, right? So not a problem. Okay, but otherwise you can see the queue length is very, very low. It's almost zero, right? Almost zero. So no transaction is waiting. So which means it's probably look, both a low queue length is a problem and a high queue length is a problem. Both are problems. Okay, a low queue length means that your EBS volume is over provisioned. right? You have a very fast volume, or you have a very big volume compared to your server. Okay, your server is simply not sending enough transactions, right, to keep the EBS volume busy. All right, so that's a problem with the low queue length. If your queue length is high, then obviously the EBS volume is a bottleneck, right? So you need to change something. Maybe you need to make it faster by changing the volume type, right? Or you can increase the volume size. You can implement a RAID configuration. So you can do many things to improve your EBS performance, right? But first you have to sort of find out what's going on, and this kind of chart will tell you. All right. Okay. So this is CloudWatch basically, and very important service, right? Very important service. So as soon as you go live, you have to sort of implement a full monitoring system, and CloudWatch will play an important part. All right. So let's stop here. Let's do a little bit of Q&A on the management tools, especially, right? So we've seen 3: CloudWatch, Trusted Advisor, and also CloudTrail. Right, so let's discuss this, and we have one more left, CloudFormation, which we will do on Monday. Okay, so so this question here, Rao, CloudWatch, is it default or does it cost? No, so it is. You know, there's something called basic monitoring, right? Basic monitoring, which is free. Okay, which is free. It's not just free tier, right? It's just free forever. Okay, free forever, not just free tier. All right, and then you can turn on detail monitoring, which has a slight cost, small cost. So then you can turn on detail monitoring. This has some cost, right? Very small. Remember, you know, when it comes to cost, the most of the cost comes from EC2 instance cost. Okay, the cost of running an EC2 instance. The other costs like network cost, monitoring cost, all those are very small part. Nothing to be concerned about too much. All right. Next question: does it work with application logs as well? Yeah. So you have to set up a log agent. Okay, a log agent has to be installed on your servers. Okay, this agent will push, or it can stream, actually it will stream the log files into CloudWatch. All right, any log file, it doesn't have to be application, any log file, right? And then in CloudWatch you can create metrics from those log files, right? From those log files. Example, you know, metric can be how many times does this error occur in the log file, right? So this kind of metric you can create, and then once the metric is created, you can track it like any other metric. Okay, so that's possible. All right, Valen, can I use the Nagios Zambix monitoring tool? Yeah, you can use whatever you want. Look, I know a bit about Nagios. Okay, I don't know about the other one, but I know a bit about Nagios. You can use this, right? You can use whatever you are currently using. Right? That's normal. Okay, a lot of people will not want to change what they are already using. Right? So you can use that, but I think CloudWatch will be much better. Okay, Nagios. What I remember of it, I used to use it many years back. Was, you know, the setup was very hard. You could monitor things like, yes, you could monitor things like, is it servers up or down, right? But other things, other metrics were not that easy to set up, right? So you can evaluate, right? I think CloudWatch will be much better because it just works out of the box. It's free of cost, right? It's tightly coupled with AWS. So I think you'll find there's no need for those kinds of tools. Okay, so CloudWatch, this is my sense, right? My opinion is CloudWatch will be much better, right? There's no setup, no cost, a lot of metrics, right? And also it is flexible enough for you to set up your own metrics. Okay, lots of things are available, so I think it'll be much better. And also, of course, CloudWatch is used in things like auto scaling. You can't use Nagios there, right? CloudWatch also sends notifications very well. It's integrated with SNS. Nagios, you'll have to do something there, right? So you know, it just works, right? You don't have to manage it. With Nagios, you have to manage it, you have to secure it, you have to upgrade it, right? All those things are not there here. Okay, So that's why I think it'll be better. Okay. One more question here. So by turning it on, CloudWatch, will it impact the performance of the servers? Not really. I mean, look, we don't know. It might, right? We don't know for sure because um, we don't know exactly how it works, right? But presumably AWS has taken care of it, right? Uh, Presumably they have some way of isolating the collection of data from the performance of your servers, right? So I think no. I think no. All right, but maybe a little bit, right? It's not perceptible, right? It's not perceptible. Nobody complains about it, right? But yeah, so you shouldn't be concerned about it, right? I don't think you should be concerned about it because uh, it would be a very big issue if it was, right? Okay, so I don't think it's a problem. Now, if you set up some agents, right? If you set up the log agent, if you set up some scripts to push those things, right? Those can affect your server performance, right? So you may set up a log agent, uh, some Perl scripts, right, on your servers to push data. Right? So these things can affect. I mean, they will use up some CPU, some memory, right? So these things can have some effect, right? All monitoring can and maybe it does have some effect, right? It's a matter of how you handle it, right? What frequency you send the data out, right? So you have to manage it, okay? Because monitoring also is important, right? Performance is important, but monitoring also is important. So you have to just make sure that it is even if there's an impact, it is manageable impact. All right, okay, folks. So any other questions, please let me know. But here's where we are, right? In the course, here's where we are. This is the end of week 2, right? This is the end of week 2, and we are we've finished about 2/3 of module 7, right? So just 3 more modules to go, along with a bit more of module 7, right? This is what is left in this course. So now you have a weekend, right? Hopefully you'll find some more time to practice. So you can practice auto scaling, you can practice load balancers, databases, and we can do a review, right? So if you have any questions around your practice sessions, we can do a review on Monday. Maybe we can spend half an hour doing that. All right, okay. And as always, you should try and read up on the upcoming topics, right? So we'll be discussing cloud formation on Monday, and then we'll look at Lambda, very important topic, very interesting topic. We'll look at some messaging services like SNS, SES, SQS. We look at Beanstalk, which is a platform for developers to quickly deploy their code. IAM in module 9 is very important. Identity and access management. So all these things are coming up. All right. Okay, folks. So if there are no further questions, right? Let's now. I think those of you who need to leave, right, can leave. I think we'll conclude this module, right? But some of you may have some additional questions, right? Especially, I think Gajendra, you might want to discuss the problem you're having with the MySQL client, right? So any of you who want to discuss those types of problems can sort of stay back, and we can talk about those. All right. So those of you who are leaving, thanks for joining. Have a good weekend. I'll see you on Monday. All right. Okay. So let me look at this question first, right? Valen can deploy a Bitnami mail server app. Yeah, you can deploy it, right? Just deploy it on. You can choose a mail server app, Army, right? Choose a mail server Army and deploy it, right? If you have any specific issues around that, you can let us know. But look, in general, right? I don't want to get into any sort of like a support for your regular activities, right? Let's focus more on the course, right? And the topics that we have covered. All right. Informally we can help you a bit, but it's not. It's like beyond the scope of this course. Okay. In general, I would say just pick a right army. Okay, pick the army for the mail server and launch it. Okay, and see what happens. And look at the Bitnami documentation for further steps. Right. Okay. So here you just have to pick an army and launch. Okay, and Bitnami will have documentation hopefully, right? So Bitnami documentation for next steps, right? So just try this and see what problems, if any, you are facing. All right. Okay. Gajendra, if you can help with the connection to RDS instance. So you have a Windows client, and my other PC has Mac. How do I connect to an EC2 server and run some commands? Yeah. So look, first of all, on the RDS instance, right? To connect to the RDS instance, it's best if you do it from EC2. Okay. So let's avoid the SQL workbench or whatever, right? Because there's no need. Normally when you create an RDS instance, you have to connect from an EC2 instance normally. Okay. So what I would say here is connect to RDS, right, from EC2, say an Ubuntu server. Right? This is the easiest way in which you can do that. All right. If you avoid for the moment, right, once you become more familiar, it will become easier. But avoid for the moment connecting from your own computer. All right. This will be much easier. Okay. At least you'll be able to connect to RDS and get going that way. Okay. And the way to connect is you simply you do an SSH to the server, right? So you do from your computer, you do an SSH, right? Let's say Ubuntu at IP address, right? Once you do that, you reach your server, right? This is your Ubuntu server, right? This is your Ubuntu server, and here you can say MySQL, okay? MySQL minus H. This is your RDS endpoint, right? And then you say minus U, which would be whatever username you have set up, right? Yeah, root user, and then minus P. Okay. You can also that's about it. Yeah, this should be enough to connect to the RDS server, right? Now, if you don't have MySQL, right? If you don't have MySQL client, then before this, I mean, if you don't have MySQL on the Ubuntu server, then before this, you may have to install. MySQL, right? So you can say apt-get update, right? And then uh, and then and then you can do apt-get install MySQL client. So this package, let me just check. MySQL client package on Ubuntu. So yeah, so MySQL client should be there, right? MySQL client should be there. So yeah, this should be there. So this is what you have to do, right? So log into SSH to your Ubuntu server, do apt-get update, then apt-get install MySQL client, right? This will let you run this MySQL command, okay? And you should then see the MySQL prompt. You can run your MySQL commands like create table, create database, all right? Okay, now shall I do it from the Windows PC or Mac PC? Either way, right? Either way, look, whatever you're comfortable with. Okay, it's these things are not important because it's just a client, right? Once you connect, Once your SSH connection is there, all the commands are the same. It doesn't matter where you connect from, right? So for Windows PC, you have to use SSH, right? SSH. I'm sorry, you have to use PuTTY, right? PuTTY for Windows, you have to download the software and then you have to use it that way, right? And on Mac, you can use the terminal program the way I'm using, right? So terminal for Mac. So just the client, right? The SSH client is different. SSH client is different, right? A little bit, with PuTTY, there's an additional step involved in converting the PEM file to the PPK file, right? So I would say Mac is easier to some extent, right? But I don't want to discourage you from using Windows if that's what you use normally, right? So you should use what you do normally, and it's not that hard, right? If you're facing problems connecting from Windows, try it from Mac first, right? So that you become a bit more familiar, right? And then later you'll figure out how to do it from Windows as well. Okay, so and it's the same protocol, right? Just the client. Yeah. Try from Mac. It's the same command, right? We have seen it many times, right? This is the command from a Mac. Okay, the command is the same from PuTTY as well, but just the GUI is different, right? GUI is different. One more step is involved, but on a Mac it is simpler. Okay, and don't forget, you have to sort of before you SSH, right? Before you SSH, you have to change mod, right? So on a Mac, when you connect, right? On the Mac, when you connect, right? You have to download the key first, right? When you launch the server, so the key should be protected, right? So you have to say change mod key.pem. This is important. All right. So to secure the key, then you can run your SSH command, which is basically SSH -i key.pem ubuntu @i. Right? That's it. So then you should be in. You should be in. If you're not getting in, then it's probably a firewall type of problem. Go check your security group to make sure that the source IP address, your IP address is allowed. Okay, so this change mod is a step you may have to do. Otherwise, it'll say permission access denied because the key is not secure. All right. Okay. Yeah. Let me know. Maybe you can just try this a bit, right? You can try it now. See if you can SSH into it, right? You can try it now. All right. Next question. You have Windows client. The other one is Mac. Yeah, so this we have discussed, right? So so let me just copy this here, right? Let me just copy this here and paste it. Okay. Okay, Rao. Yeah. Okay. So Rao, you have 4 AWS accounts, say for different accounts, and each account is in a separate VPC. Yeah, and we create a single VPC with a private subnet that can access corporate network. And I can use the VPN gateway for other AWS accounts on different VPCs. Yeah. So you have to peer it. Yes, it should work, right? I replied to that ticket. Your question had come to me, but it should work. I haven't tried it. It should work. Okay, what you have to do is you have to peer. You have to peer the VPCs. Okay, you have to create a peering connection between the VPCs, and you can peer VPCs that are in different AWS accounts, right? And also make sure that each VPC has a different IP address range. Okay, IP address range. Otherwise, you'll have IP conflict. Okay, otherwise you'll have IP conflict. So, so if you, as long as you do all this, you should be able to make it work, right? You can start simple. Just start with, say, 2 VPCs in 2 accounts, right? And then create the VPN connection and see if it works. Okay, it's possible. I think it'll work, because I definitely know that VPCs can be peered across AWS accounts, right? And if they're peered, then you can easily reach from one VPC to the other. Yeah. And also, how you will peer is important. You have 4 VPCs, right? So you have to sort of maybe peer one first VPC to the second one, then the second one to the third one to the fourth one, right? Or are you going to have a different topology? There's also different network topologies possible, like a star. Let me see if I can find that for you. Um, um, I'm not able to find it. Okay, so here it is, right? VPC peering scenarios, right? So in this, you can see, you should see, let's say, peering two or more VPCs, right? So you have this one, say three VPCs paired together. Right? So this is the kind of topology you need to have, right? So you can, basically go through this page here and see what scenario works best for you. Okay, because there are lots of ideas here. You have to see how you're going to connect those four VPCs. All right. Okay. Yeah. So Gajendra, yes. So you can try it now, right? You can try it now. Let's see what happens. Okay. So Valen, if you're trying this, let me know, right? If you're trying this, let me know. Let me first see if there's a mail, if there's a mail server army here, right? So in the army, community armies, let's say mail server, right? Mail server, let's see. Okay, let's see if I can type Bitnami as well. Yeah, I don't know. I mean, which one? If you have a name, right? If you have a name for that army, you can let me know. You can let me know. Right? So it doesn't look like there's a mail server from Bitnami here. Uh, I mean, there are lots of other applications, but I don't know if there's a mail server. Yeah, so it doesn't look like the mail server army. Um, yeah, yeah. So you can, what you can do is you can install a server and then install a mail server on your own. Okay, but I think there is some limitation on mail servers on EC2. Let me just try and find that. Yeah, so I think it's fine. I think it's fine. A lot of people do it, I guess. Because emails are normally controversial, all right? So because of spam. So this is what I was trying to find. Look, there's a process you have to go through to allow outgoing email. Okay, uh, so you have to tell AWS that you will be sending emails from that server. Okay, because it is controversial from a spam perspective. Okay, so let me share this link with you. You have to make sure that you take permission, right? Well, not take permission, but at least inform AWS that you will be sending emails from this server, right? Inform AWS before sending email from EC2 instances. Okay, this is very important. Otherwise, your emails will not go. All right, and this one, Bitnami. Okay, let's take a look. Okay, so yeah, Mautic was there. Like this one was there. Let's see this one, round cube. round cube. So yeah. So this seems to be available, right? So just select this, right? You can just select this and it should get once it launches, right? You have to go and see the documentation to see how to access the application, right? It should be pretty simple. Okay, but I would still sort of contact AWS and let them know that you'll be sending emails from this server. Yeah. Okay. So I don't think that'll be an issue to launch this server. Okay, so this question, Valen, how to connect a VPC, how to connect to a VPC using a VPN connection, right? So how to create a VPN connection. So there's a that scenario, right? Let's take a look at that scenario. Let's say scenario 4. Okay, scenario 4, VPC. So do you have a hardware? Do you have a hardware VPN in your office? Okay, so you can basically use the wizard to create scenario 4, right? And then you have to set up your customer gateway, right? Yeah, so all this, you have to basically set up the customer gateway on your side, all right, and for that you need to know things like static IP address or the range of IP addresses that you'll be using on your network side. Okay, this is a little tricky bit here. If you have access to a network person, a network administrator, that will be helpful. Okay, from the AWS side, it's pretty. Okay. Yeah, 3 and 4. Yeah, either one, 3 and 4. So this is only software, is it? The software firewall. No, software. No, do you have a hardware VPN? Not firewall, hardware VPN. Because this scenario talks about a hardware VPN here. Okay, so if it's a software VPN, then let's see. Yeah, so then you have to use this one. Okay, so what you have to do is you can create. It says here you can create a VPN connection to your remote network by using an EC2 instance in your VPC that's running a software VPN appliance. Yeah, so this option is what you have to use then. Okay, using an EC2 instance with a VPN software running on it. Right, that's what it looks like. is the option. Okay, let's see if I can find more documentation. Um, all right. Okay. Here's this one. Yeah, so looks like there are resources like this, right? This one talks to you about one way of connecting using a software VPN. There could be others as well. Yeah, maybe you can use this solution, which is installing OpenVPN on one of the servers, one of the EC2 instances in the public subnet. That's what these guys are using. So we'll have to try it out. I've now tried this out. Let's see what you're saying here. So what you have now is if I access my Office PC, Office machine in my home, I configure the VPN in my Office firewall. Okay. Then I install the OpenVPN software in my home PC. Then I give the public and private key, and those keys are generated in my Office firewall. Here my question is, how do I need to configure the VPN in the AWS instance? Yeah, so same thing, right? So you do the same thing. No, you configure the VPN in your Office firewall, right? So firewall is only a firewall rule, right? What VPN software are you using? OpenVPN server probably, right? You probably have an OpenVPN server running somewhere, right? In your office. So same things has to be done. Same thing has to be done. Yeah. So see, whatever you're doing today, right? Same thing has to be done. You can do a VPN. So you can launch an EC2 instance, right? Launch an EC2 instance, install OpenVPN server on that. Okay, and then the OpenVPN client will be on your home computer. Okay, so this is how it should work. It should work this way. All right. Now also remember one more thing that I can tell you is that you can avoid this. Okay, you can use a jump server. Okay, the other option without VPN, the other option, okay, which is no VPN option, is you can SSH to a EC2 instance in the public subnet. Okay, in the public subnet, right? From this server, you can go to any server. You can connect to any server uh, in the private subnet. Okay, so this way also you can do it, right? This is much simpler. This is what I do normally. Okay, I don't use a VPN connection. I just SSH to a server in the public subnet, and then from there you can connect to RDS, you can connect to any other server. Okay, so this is also one option. Okay, so yeah, so Gajendra, how are you? How are you doing? Let me know. Um, okay, but the problem is your .NET Dev is asking for the DB IP only. Okay, so the but what does he do with the database? Does he use some kind of uh, see, because look, it depends on what he's doing with the database, right? Is he connecting to the database for like MySQL commands or something like that, or then they're connecting to MS SQL? Okay, so why can't they RDP or SSH or MS SQL GUI? Okay. They're using the MS SQL GUI. So can they not RDP to a Windows server on public subnet and then use RDS from there, right? So instead of connecting directly to the database from your local machines, they can use you can connect from from one of the servers in the cloud. So this these are some ways, right? These are some ways. Either you do a jump server type of thing, or try this OpenVPN solution, right? Uh, okay, so anyway, you can try it out. You can try it out. Maybe we can talk about this more uh, once you've had a chance to look at these options. Yeah. Yeah. So okay. So Gajendra, you're saying it says no such key file, right? So that key file is just a key.pem is something you should have created and it should have downloaded on your machine, right? So when you create the instance, the last step is where you create a key file, right? So what was the key file that you created over there? Okay. So it's the same, that you should not say key.pem. You should say whatever key file that you had created. Yeah. Yeah. Okay. Okay, so Valen, I think the billing problem is definitely a card problem, right? Maybe the CVV is not entered or something like that. You can speak to your bank, and hopefully they'll help you. Yeah. Yeah. Gajendra, whatever key pair you had selected there, right? You should have it also with you, right? You should have it with you, or you have to, create a new key pair when launching the server and download it at that time. Okay, when selecting the key pair, how do I download it? No, so okay, let me show this to you, right? Let me show this to you. So let's say what you have to do is, let's say we are creating a new instance. Okay, so let's in fact let me go to the other region. Uh, okay, so let me show this to you quickly. So let's say, it's an Ubuntu server, right? And we're launching this server. What you should also do in the security group, right? Just to get started, choose the default security group. Okay, this allows all, uh, it's basically very open, right? So use the default VPC. This is open, so you can connect easily, right? So this is one. And then when you're launching, right? When you're launching, it says select a key pair, right? So you can, if you don't have a key pair already downloaded, choose create a new key pair. All right. So instead of saying choose an existing key pair, which you do for the next server, right? For the first time, say create a new key pair. All right. And let's say this is your key pair. So let's say let me give this your name. Okay. So let's say this is your key pair. Okay. So just give whatever name, a unique name, and at this point you have to download it. Okay. So download it at this point, right? So now I have .pem file on my machine. Okay, once it is downloaded, you can launch the server. All right. Okay, so that's done. Now this, from your terminal, right? This is my terminal. Now I have to copy this. Now the way to connect this would be, you have. Let's wait for this server to come up, right? So now you have this server. Okay, so what you do is you have to do SSH -I, right? The file has been downloaded in the downloads folder, right? So you have to give the correct path there, and you can see it says gajendra.pem. Okay, so make sure the path is right. All right, and then you say Ubuntu @ public IP address, right? So this is how you would connect. But now it'll give you an error because the key file is not protected, right? So that's why you can first say change mod, right? So you say change mod 600 downloads, and then right. So this you do so that it's secure, and then you should be able to connect like this. Okay, so now it should connect. There you are, right? So this is the Ubuntu server. Okay, so it looks like the problem is with the key, right? The problem is with the key, and okay, so I hope you got that. I hope you got that. So yeah. So Valen can help maybe. Yeah. Okay. Yeah. So it's just a matter of just making sure that your key is available with you, right? And it's in a path that you can access, right? And you have done a change mod on it. That's it. All right. Okay. So good luck, right? Good luck with that, and hopefully Valen, along with Valen, you can work this out. Otherwise, we'll talk on Monday. Okay, we can talk more on Monday. All right. Okay, folks. So let's end the session here. Have a good weekend, by the way. See you on Monday. Bye.